So here's the first of several texture slides that we're going to be covering that talk about how is it that we're going to wrap our geometry with images to make it look a little more realistic. So first, let's talk about some of the various topics under texture. We're going to be looking at how we can load images dynamically from a file system and then try to map the pixels that are on an image, right, and be able to then transform each one of those pixels into the geometry. So we need to understand how is it that, as you iterate over the various pixels that are on an image, how does that translate to pixels on the screen, right, mapped onto a surface, right? Whether that surface might be, a very complex polygon or just a simple triangle or sphere or cylinder. And so we'll take a look at how is that all the different transformations that are required to go from the image space, right? That is a 2D image, right, going horizontally and vertically. How does that translate into a 3D space, right? That needs to be mapped onto some kind of surface that has been rotated, translated, scaled, and so we need to compute where does that pixel in every image falls onto a surface. We're also going to take a look at if you have an image that might represent some environment that as we look around, we inside of a room or inside of a we're outside in the woods or in open spaces, right? And you want to be able to represent that and then use that image to map it onto a surface. You can use that technique to model things that are very shiny, right? If you look at a metal ball or something that is very shiny, or maybe the window on a car, or even a surface of a car that's very shiny. You can see the reflection of the environment around the car, reflected on top of the hood or the window of the car, right? And so how is that can we simulate that, right? It's basically we need an image a 2D image that represents a spherical environment around the car, right? And then map it and wrap the car and wrap the hood and the and around the doors and everything, with the surrounding environment. So environment mapping, allows to add quite a bit of realism to our images. We're also going to take a look at bump mapping. Bump mapping is a technique that that allows us to simulate fairly complex surfaces that otherwise would be extremely difficult and extremely inefficient to represent, right? When you see like a wood grain, right? If you look at wood, it might have several indentations and has several veins on the wood, or even if you have an orange that have all these dimples that are somewhat random along the surface of an orange. How is it that you can simulate that, right? The hard way of doing that is that you actually use the various triangles to represent all those valleys and ridges around the surface of the earth, or around a surface of a fruit, or the surface of a wood grain, right? And so that would be extremely expensive. So instead, we can achieve somewhat the same kind of look and feel by looking at the various normals that are defined along the surface, and varying those surfaces normals, right, so that we can then calculate what the lighting might be at each one of those pixels without actually representing each individual geometry triangle, right? We can instead calculate in our fragment shader. We can calculate what the normals would be, if indeed this would be an actual surface with actual triangles, right? We can modify just the normals, very much like we did in Phong, right, where we can do a smooth shading, even though even though the surface might be flat, right? You can simulate as if it would be a smooth shading by interpolating the colors from one vertex to the next, interpolating the normals as well. Well, here too, right? Instead of being something smooth, we can add some noise, right? We can add some randomness to those normals that deviate from the normal, right? And so that would create that kind of granularity around a particular surface. We're also going to consider a couple of strategies on how is it that you would implement this. Whether you start off from an image and the various pixels, and you iterate over the pixels in the original image, and then calculate how that goes and maps to a surface, a 3D world surface, and then eventually how that maps to the window where that's being rendered on the screen, and that's called forward mapping, right? That you start off with the image, right, and then you move towards how does that render in the screen. But also one way to do it simpler would be to do what is called a backward mapping, right? Where instead you start off from the screen, right? You look at a pixel on the screen and says, okay, well, what is the image, right? That would need to be rendered at this portion of the screen. That you can map onto some surface on a 3D object, and then that can then map back to an image and go get the pixel that would be mapped to that. So forward and backward mapping, we're going to see pros and cons of using one or the other, and we'll see that backward mapping is actually a little more efficient. Also, we'll take a look at the strategies of using point sampling versus area averaging that deal with issues of sampling, and where you might be, when you're sampling the image, right? The image, you're looking at each pixel, and you as you iterate, vertically and horizontally over an image, a GIF image or JPEG image, and as you take, the color of each one of those pixels from the source image, if you consider every single pixel, then obviously you're not going to miss out on any original pixel in the image. But oftentimes, if you have a very small polygon, right, where the sizes of the polygon and the sizes of the source image don't quite map one to one, oftentimes you might be oversampling, right? Where just a few pixels, 10, 20 pixels in a source image might only be represented in a single pixel on the screen. So you're kind of oversampling, too many pixels from the source image on, just to render a single pixel on the screen. So oftentimes it's the inverse, right? Where you might have, 20, 30 pixels on the screen, but you're only sampling 1 or 2 pixels from the source screen. And so we're going to take a look at how is it that we would deal with this issue, whether you're oversampling or undersampling, and you might be skipping over, relevant pixels in the source image, and they're being rendered incorrectly on the destination of the screen.